All right, let's dive straight into this explainer and build your ultimate site survival playbook. Welcome, everyone. If you're stepping onto a construction site as a junior engineer, an estimator, or a quantity surveyor, you are absolutely going to be judged on your ability to make rapid, accurate decisions. Concrete is the lifeblood of almost any build, and today we're going to master exactly how to calculate the materials you need for a standard concrete slab. We are going straight into a high-energy, fast-paced how-to that will completely transform the way you estimate. Because out there on site, speed and accuracy in calculation isn't just nice to have. It's your ultimate competitive advantage.
So, what is the single most expensive mistake a rookie estimator can make, especially on a high-stress Saturday pour? It's a massive trap, and it's simply this: assuming your wet concrete volume equals your dry material volume. You do your initial length times width times depth calculations, you get your cubic meters, and you think, great, I'm done. You order exactly that mathematical amount. But here's the reality check. Construction is not a pristine math problem on a whiteboard. These materials behave radically differently when mixed with water compared to when they're sitting dry in a pile. And if you fail to account for this transformation, the financial and structural consequences are literally immense.
Just listen to this real-world disaster from Gilbert Concrete to see what I mean. Running out of concrete when the main truck has already left is an absolute nightmare. They had to pay a massive $425 premium for an emergency delivery of just 1.5 yards of concrete. But actually, it gets so much worse than a hit to the budget. Because of that delay waiting for the emergency truck, the crew was forced to create an unplanned construction joint. The initial concrete had already started to set, a cold joint formed, and as they noted, just 2 winters later, a crack formed along that exact line. Because of a basic estimation error, they essentially built a permanent failure point right into the foundation of their project.
To survive out there, you absolutely must understand the fundamental difference between wet volume and dry volume. Wet volume is your finished product. It's compacted, placed, and it's exactly what your formwork dictates after the water has been added and the mix leveled out. But dry volume? That consists of separate, loose materials that are full of hitting empty air spaces. When you add water and start mixing, the finer particles like the cement and the sand, they rush in to fill the gaps between the larger rocks. The overall volume shrinks. Because of this, you actually need significantly more dry material to yield 1 single cubic meter of finished wet concrete.
Okay, listen up, because this is literally the ultimate quantity surveyor trade secret, the 1.54 dry volume conversion factor. This is the exact number that separates the seasoned pros from the amateurs. If you only remember one single number from this entire explainer, make it 1.54. To get your required dry materials, you must take your calculated wet volume and multiply it by 1.54. It is the absolute bedrock of manual concrete estimation. But as a professional, you shouldn't just blindly memorize a number, right? You need to actually understand the physical mechanics behind it.
So here is exactly why 1.54 is the magic number. Unmixed, dry materials contain exactly 54% empty void space. It breaks down like this. You've got about 34% air hiding inside that coarse gravel and another 20% trapped in the fine sand. Think of a bucket filled with large, chunky rocks. There's a massive amount of empty space between those rocks, right? That void space in the coarse aggregate makes up that 34%. Now, if you pour sand into that same bucket, the sand fills those gaps beautifully, but sand itself has tiny voids between its grains, accounting for that other 20%. Add them up, and you have exactly 54% void space. So to get 1 cubic meter of solid compacted wet concrete, you need 1.54 cubic meters of dry ingredients to start with.
Let's put this into practice and decode a real-world scenario. Let's look at the classic M15 grade, which gives us the standard 1:2:4 nominal mix ratio. Now, different jobs require different strengths of concrete, which we call grades. You've got your M10, which is a lean mix used for basic leveling, while M20 is a much richer mix for structural planning. But for general concrete work, like your standard footings and normal slabs, the M15 grade is your absolute bread and butter. And that 1:2:4 ratio? It simply means 1 part cement, 2 parts sand, and 4 parts coarse aggregate.
For this 1 part cement, 2 parts sand, and 4 parts aggregate mix, you need a repeatable framework to calculate your required materials on the fly. Picture this scenario. You're out on site, the forms are perfectly set, the subgrade is prepped, the mixer is literally idling right there, and you need to tell the crew exactly how many bags of cement to pull from storage for a 1 cubic meter batch. You do not have time to go pull out a textbook. You need a fast, bulletproof calculation sequence that you can punch into your phone's calculator in under 30 seconds.
All right, here is your high-speed calculation drill. Let's walk through it.
Step 1, we start with our goal, which is 1 cubic meter of wet concrete. Step 2, we immediately apply our magic secret factor, multiplying by 1.54 to find our required dry volume. Step 3, we add up the parts of our M15 mix. 1 plus 2 plus 4 gives us 7 total parts. Step 4, to isolate the cement portion, we take our total dry volume of 1.54 and we divide it by those 7 parts. That gives us 0.22 cubic meters of pure cement. And finally, step 5, cement is usually delivered in 50 kilogram bags, and one standard bag occupies a volume of exactly 0.0347 cubic meters. So we just divide our 0.22 by 0.0347. If you run that math, boom, you get 6.34 bags. This establishes the unbreakable rule of thumb. You always need 6.3 to 6.5 cement bags per cubic meter for a standard 1-2-4 mix. This is the exact kind of metric that allows you to instantly verify material deliveries on site. If you know your slab is exactly 10 cubic meters, you know instantly, without any hesitation, that you're going to need around 64 or 65 bags of cement. Keep in mind, if you were running that richer M20 mix, the 1 to 1.5 to 3 ratio, that number would jump up to about 8 bags per cubic meter. But for our everyday standard M15, 6.5 is your rock-solid baseline.
Now, here's the real pro move. Making a perfectly accurate calculation is totally useless if you don't factor in the messy realities of an actual job site. Amateurs trust the pure geometry of their tape measure, and they order exactly what the math dictates. But professionals, we know that pure math doesn't pour concrete. You must always add a waste factor to your final calculation. A 5 to 10% buffer is the standard safety net that guarantees you're never the person who runs out of material during a critical pour. Adding that 5 to 10% waste factor accounts for all the inevitable things that go wrong. Let's be real for a second. Wheelbarrows tip more, mixers splash, and cement bags sometimes just break open in storage. But more importantly, the earth beneath your slab is never a mathematically perfect, totally flat plane. Even an extra half-inch of unexpected depth across an entire garage floor due to a slightly uneven subgrade, that will eat up hundreds of dollars of concrete you didn't plan for. And if you're dealing with complex geometries or curved formwork, which are notoriously tricky to build perfectly tight, you should automatically push that waste factor to a full 10% just to be safe.
So, armed with the 1.54 secret and this rapid-fire calculation framework, you are more than ready to hit the site and guarantee your next pour goes flawlessly. You now understand the profound, crucial difference between wet and dry volume. You know exactly how to decode a nominal mix ratio, and you have the step-by-step mental formula to calculate your cement bags totally on the fly. Plus, you've got the professional foresight to factor in site realities with a smart waste buffer. Speed and precision are your sharpest tools out there. So, the next time that mixer rolls up and the foreman yells out for the cement count, will you be the one with the immediate, accurate answer? Keep practicing these frameworks, trust your math, and go build with confidence.